guys, this is an exciting day because this is our last video of the year of AP Stats, period. And this is just a day where we are going to look at the formula chart and also just some common mistakes on the AP free response. So I hope you have these two in front of you. I want you to put the formula chart at the front of your binder. And you really only need the first 2 pages because we don't use the tables for normal and T distributions. We only use we use our calculator for it. So a lot of these formulas you already have on the review pages that I've printed out for you, but this might be a quicker way to access them. So I kind of just want to talk through how to use the formula chart and what it's helpful for, and also what are the parts that you don't need. So if we look at the first half, this is units 1 and 2, which is all of the 1 variable statistics, 2 variable statistics. So first line, 1 variable, 2 variable. This is for calculating the mean. We calculate the mean and the standard deviation in our calculator. So mean plus standard deviation in calculator using 1VARStats. So we really don't ever need to use those. I don't think there would be a time where you would forget how to use your calculator to find the mean and standard deviation. The next, so this is the LSRL formula, where A is your y-intercept and B is your slope. Don't forget your hat. So if it ever asks you to find the LSRL, remember that you need to define your parameters and don't forget the hat. So these two formulas are if you were given like X bar, Y bar, and you were also given SX, SY. So if you were given all 4 of those, you would use that to find the LSRL algebraically. I don't really think they'll have that on there, but just in case. And this is to find your correlation coefficient by hand, but you really don't need that because you can do that on your calculator. And the next section, so section 2, that is going to be unit 3, or unit 4. There are no formulas for unit 3, which is the experimental design, but this is probability. This is the OR formula. So A or B equals A plus B minus A and B. And this is the second one is the conditional probability, which is the probability of A given B equals the probability of A and B over probability of just B and over given. So that's just a quick way to find the conditional probability. The next part, this is also unit 4, but we're getting into discrete probabilities. Discrete random variable X, this is like the very first part of that unit 7 chapter whenever you were given it in a table. So given probabilities in a table. And it wanted you to find the mean, like the expected value and the standard deviation. When you have something like that, I would say, I told you how to find the expected value, which is your value times your probability added together. Like if you had 0, 1, 2, 3, 0.2, 0.3, 0.2, 0.4, something like that. I don't know. And you would take your value times your probability plus value times probability, and you'd add those together. So that's the formula for that. Standard deviation is a little more complicated, and we don't use that one. So we use the calculator. L1, L2 is our frequency list, and do 1VARStats for that. So L1 is our list, L2 is our frequency, and then we calculate 1VARStats, and that'll give us our mean and our standard deviation. For binomial distributions, remember that's whenever you have a fixed number of trials. Your mean is n times p. Your standard deviation is square root np 1 minus p. And we can just use binom PDF and CDF for these, even though this is like the technical formula for it. Geometric distribution, that's where it goes on forever. So you would see the words first or until. Mean is 1 over p, square root of, and standard deviation is square root of 1 minus p over p. These are new this year, and they did not have those last year. So fun fact. And then we get into part 3 of the formula chart, and that is units 5 through 7, which is all inferential statistics. The first two are the formulas that are just the generic formulas. So a test statistic, that's either your Z or your T. That's a test statistic. And then your confidence interval would be your statistic, which could be X bar or P. Your critical value, which could be Z star. I guess I put X bar first. So T star or Z star. And then standard error, which is your standard deviation. And this whole thing is called your margin of error. Now, I have all the formulas laid out for you, so I don't really think you'll need this, but you could, I guess. So if you want to reference that. The last thing on this page is the chi-square test statistic. We never even got to that. That was unit 8, and so just cross that out because we never used anything for that. This last page is actually really helpful, I feel like, because these are the formulas for the sampling distributions. So finding the mean and standard deviation for one population versus two for proportions. These are proportions. And then for means. And then this one would also be if you have it a match pairs. But it would be like the difference. Something interesting that I feel like they've never included before is your p hat c, which is your combined proportion. And that's what you use for the formula for two sample proportion. You use p hat c. So that's there, that you just take your total values divided by your total sample size. I'm trying to think. These S's are like when sigma is unknown. You'll use S versus sigma. But for sampling distributions, typically you are given your sigma. So this is just a reference. I do have, obviously, the formulas on that table too, so you don't necessarily need to use this, but it gives you the mean, the standard deviation for all sampling distributions, proportions and means. And then the last part, this is for LSRL, and that was unit 9. We never got to that, so cross that out. You will not be using that at all. And then the last pages, those are the tables. You don't need to print those out, just have the first 2 pages. So keep this at the front of your binder if you need to reference this during the test. It's just right there. But let's go to the next page, which is the common mistakes page. Okay, so these are the most common mistakes that students make on the AP free response questions whenever we're grading and seeing what students know and what they understand. These are the things they get the most points counted off for. So in unit 1 through 2, which is all one variable, two variable statistics, first one is when asked to compare two sets of data or distributions, students just list the key, like the key statistics. They don't compare. So remember that you need to use comparative language, like less than, greater than. Use comparative language. When writing out the LSRL, they forget to write y hat and identify the variables. So you can't just put y equals a plus bx. Remember, you need a hat. And a equals this, b equals I'm sorry, not A and B. You would define X and Y. X equals this, Y equals this. Even if it's listed in the problem, you need to define your parameters and write out the Y hat. Students should always comment on at least shape, center, spread, outliers if they exist, so that's cussing, on numerical graphs, or numerical data, I guess I should say. Show all your work when calculating a z-score, any math for that matter. So don't ever just write an answer, even if it's saying 2 plus 2 equals 4. You need to write out your problem. You need to write out your work, no matter what. Writing too much on a free response question answer, especially on an exploratory data analysis question. Students list all the stats that they learned and don't always answer the question asked. So you want to always make sure that you're answering the question asked. Short and sweet, move on, no extra credits given for added work. And number 6, not understanding why we transform data, make it look linear, and then interpreting the new LSRL. Remember me talking about transforming data? They're not going to make you physically transform the data, but they may give you a new LSRL. So if they had like y hat equals a plus b log x, and they used a log for transforming. So now you would say linear relationship between log x and y. So it's not between x and y now, it's between log x and y. So for the experimental design, that's usually when you're writing out how you took a sample, how you took or how you designed an experiment, or explaining the different vocab terms. The biggest thing is that students don't understand much of the vocabulary and use the words incorrectly. So if you're just trying to use a big word to use it, that's not going to get you any points. So make sure that the vocab that you're using is something that you are familiar with and understand. The second thing is not explaining how they randomize the data, but just stating that they randomly put them in 2 groups. So you might need the hat method, random number generator. It's like you're giving a how-to persuasive essay and you need to explain how you're doing it. You can't just say that you randomly put them in groups. Causation with statistically significant results. So you can have significant results, but that doesn't mean that one caused the other. The only time you can have causation is a well-designed, controlled experiment. So my p-value could be really low in my inference test, but that doesn't mean that it causes the other thing to happen. You can only say cause when you have a well-designed and controlled experiment. Confusing completely randomized versus randomized block. So think about completely randomized as an SRS and a randomized block as a stratified. You're putting people in groups first for a block, and then every block is getting all treatments. For an SRS, every single person has an equal chance of getting selected to a treatment or getting assigned to a treatment. 5, students confuse control groups with controlling outside variables. Control group means that they are actually a group that people are assigned to. So assigned to this group. Control groups are not necessary, but often suggested so that you have something to compare it to. But if you're just controlling outside variables, that means keeping things constant. That has nothing to do with a variable. With a treatment group. So I always use that example with the temperature affects your test grade. Some things that I'm keeping constant are you're all getting the same test. You're all studying, getting the same material given to you or presented to you. Those are keeping things constant, but that's not the control group. Stating the experiment cannot be double-blind because somebody needs to know what is going on in the experiment. Double-blind just means that the subjects plus the administrator or the person administering the experiment don't know what's going on. But there will be somebody that knows what's going on. So you can't just, it's not that you're double blind because nobody knows. Somebody knows. They're just up, they're created the experiment. They're the ones assigning people, but the people that are administering the test, like the SAT or something, they don't know what's going on. Using complicated methods that are hard to explain for the randomization method, put names in a hat, shake them up, works easy to explain. So the hat method, you can't really go wrong with that. Don't try to do something super complicated. And then confusing, confounding, and lurking variables. We never even really talked about lurking variables, but sometimes students like to say something about that. We didn't even really discuss that in our class. But confounding, that just remember that means that you can't differentiate between that variable and the treatment. So at the end of the experiment, I can't decide or I can't differentiate between if the reason why the people in the really low temperature room did well on the test was because of their low temperature or because they took it in the morning versus the afternoon. So I needed to keep the time that they took the test constant or something like that. Okay, the last two, probability, not showing any work, just writing out an answer for the two-way table. Like, when you have those really big tables and they ask you, like, what's the probability of male and over 50 or something. Try to show as much work as possible. I know some of them are just a straight answer, but at least put the correct fraction and decimal. Not showing any work for independence, but just commenting on their independence because they are not related. The work for independence, there's two ways. You can either do the multiplication rule, which is I guess I'm going to use the right symbol. A and B equals A times B. That's the multiplication rule. Or probability of, I'm going to use A given B equals the probability of A, or the conditional rule. So those are how you show your work for independence. And I can almost guarantee you they're going to put that on there. I don't know. They just love to do that. So proving independence mathematically. Using calculator speak for their work, not proper statistical formulas. We do use a lot of calculator speak, like for binomial, normal, things like that. The biggest thing is that if you do use your calculator for the for your answer, like if I said binom CDF 8.25, then I would say it's a binomial distribution where n equals 8, p equals 0.2. And so that's defining my parameters. And then before that, my probability statement would be x is less than or equal to 5, because that's what I'm finding. So that's defining x, it's defining n, p, and stating what type of distribution it is. And that would be for normal, for binomial. But if this were just your answer, I can't guarantee you that you would get credit for it. You would need to define the parameters as well. And not putting their final answers in sentence or context. So make sure, like, units, if it's saying what's the expected value of children, you would want to say 2.4 children. So always giving your context. And then for statistical inference, don't list the assumptions, check conditions, nor understand why they need to do this. As I've been watching these AP videos, one of the teachers on there was saying just kind of predictions on what they think that the AP test will have, and they said that they don't really think they're going to make you check conditions because you have them listed in front of you most likely from your notes, but they're going to ask you why you need to check the conditions. So why do we need to randomize? Why do we need to check the large sample condition? Why do we need to, I think those are really the only two. Why do we randomize? Why do we check the large sample? We check the large sample conditions so that we know that we have a normal sampling distribution, and then we can follow through with finding the test statistic and the p-value. Not showing a graph to check for normality when data is given, so either box plot or normal probability plot. I usually do a box plot, no outliers. Not showing their work setup or just stating their final answer from the calculator. It's okay as long as you've correctly named the test, which we do. We don't write out the formulas. Name the test. I already told you on that paper what all you need to write out. Not using parameters when you list your null and your alternative. So p equals, mu equals. We already talked about that. Not linking the p-value to the significance level when writing their conclusion. If you stick to the script, so since the p-value is less than alpha, I reject, then you're good to go. Linking the p-value to the significance level. Reversing the conclusion, I don't think you guys are going to do that. We wouldn't want to fail to. We just reject. When the p is low, reject the ho. And don't ever accept. But you guys are not ever going to do that. I really don't think you will. So your homework for today is over the weekend, or if you want to do it now, there is a mock AP exam that I want you guys to take on your own. And you're going to do this, you're going to allot 50 minutes, get a piece of notebook paper out, probably 2, because you'll do a file upload for each problem. First problem, you'll get 30 minutes, 25 plus 5 to upload. Then it's going to go away. When you move on to the next question, you can't go back. Then you'll do the second question, which will be 20 minutes, 15, and then 5 to upload. And we are going to go over the solutions on Monday before class, or I guess at the beginning of class. And then we'll take the mock exam number 2. I wanted us to get 2 practice tests in before the end. And that'll be over Zoom on Monday at 10:30. And that'll be worth a test grade. So if you guys have any questions, let me know. But I hope you guys have a great weekend.